Truck commercials are a common occurrence on television. In those commercials, they're always mentioning something about payload and torque and how they have the most torque in their class. In this case, the 2006 Chevy Silverado is named the King of Torque. I often wonder when I see a commercial like this, how many people actually understand the meaning of torque? Here's a great commercial to illustrate my point.
Need to torque this down.
Hey, Dad.
Yeah.
What's torque?
Well, son, torque is rotational force. Mathematically, it can be defined as the cross product of the vector by which the...
Hey, Dad.
Yeah, buddy.
Why can't I see my eyeballs?
Best-in-class payload and torque from Northeast Ohio's best-selling brand.
I worry I'm like the dad in that commercial where I'm all excited to start telling you about torque and you're like the son where you don't really care, you're just curious. So we'll see. Maybe you'll walk away with a better understanding of torque. The dad in the video actually had a pretty good definition of torque going before he was interrupted. If you caught it, he said that torque is a rotational force. And that's a pretty good way to think about it. Let's review the concept of a force. So I'm going to call a force the ability of a push or pull to cause a change in motion. The whole point of applying forces is to cause acceleration or affect the acceleration in somehow. If there's multiple forces acting on an object, then it's really the net force that causes the acceleration. A torque, then, is the ability of a force to cause a change in rotation, or what we can call an angular acceleration. So torque depends on force, because it's the ability of the force that produces a torque. So what that means then is you can apply a force which can result in a torque, but not every force will result in a torque. So you can have force without torque, but you can't have torque without force. Torques also share that behavior where if you have multiple forces that are causing multiple torques, then really it's the net torque that causes the change or the angular acceleration or the change in rotation. So let's look at a device that strongly utilizes the concept of torque. This is just a wrench. And over here I have a bolt, the head of a bolt. And let's say that we want to loosen that bolt. So we're going to have to rotate this thing counterclockwise. All right, as we think through this step, let's try to determine what factors affect torque. Okay, so just imagine most people have had some sort of experience loosening a bolt or turning something. So it's somewhat intuitive. So just try to imagine the last time you did that. The first factor is going to be fairly obvious. We have to apply a force in order to change the rotation of this bolt. So obviously force is going to have some effect. And I'm sure you know that if I increase the strength of my force, I just push or pull harder, then I'll have better results as to my ability to rotate this thing. And remember, the whole point is to change the rotation. If it's at rest, if it's a stubborn bolt and you want to loosen it, then you're really trying to change that rotation. Okay, so clearly the first factor is going to be the strength of the force that you apply. Now what if I take the same strength, but instead I apply it over here? So imagine that the tail of this arrow is where I'm applying the force. This bolt is what we call the pivot point or the rotation axis. So what I'm showing you is I'm applying a force very close to the pivot point. Well, hopefully your intuition is telling you that that's really not going to do a lot. It can apply some torque and you might have some effect, but if it's even stubborn at all, then that's not really going to do very much. You probably also know that if instead you apply the force on the other end, then you'll have a lot better results. It's much easier to turn that nut or bolt. Okay, even better, use a longer wrench. and apply the force at the end of that wrench. Well, what if you don't have a longer wrench? You can do what I call a cheater bar. So you slide that over the top, which has the same effect as a longer wrench, just allows you to apply a force at a further distance away from the pivot point. So what we're observing then is that another factor affecting torque is the distance the force is applied from the pivot. And remember, the pivot is the bolt in this case. Well, as a way to try that on your own, if you don't happen to have a stubborn bolt and a wrench handy, just next time you go to open a door, instead of pushing in the typical spot by the handle, try pushing over on that side. This is the side near the hinges. Okay, the side opposite the door handle. Just try it. Next time you go to open a door, try pushing on the inside near the hinges, and you'll find that the same amount of push that you normally have to use does much less. Yes, much less effect in opening the door. So if you wanted to open the door, you'd have to push a lot harder. Whereas if you use the door handle like normal, then it's relatively easy to open a door. So you're seeing the effect that distance has on torque. And when I say distance, in this case, the rotation axis is this whole right side of the door. And so the distance would be this perpendicular distance from that rotation axis. Okay, another situation. What if we apply that same force that I keep showing, but we apply it in that direction? What do you think is going to be the result as far as your ability to change the rotation, or in other words, to apply a torque? Hopefully it didn't take you very long. This isn't going to do anything. It doesn't really matter how hard you push. It's not going to loosen the bolt, even if it was already loose. This would cause no rotation, no change in rotation. Okay, well, what about this situation? Same force, but now we're pulling it away. Well, it's probably pretty obvious that for an open-ended wrench like this, that would just pull the wrench away from the bolt, and so it wouldn't do anything to help you change its rotation. But even if I use this close end here so that I couldn't actually pull it away, it wouldn't have any effect on turning the bolt. So what we say then is that has zero torque. Same thing with the previous situation. If we're pushing towards the bolt, then that has zero torque. Zero ability to change the rotation of the bolt. So the point I'm trying to make then is that the direction of the force clearly does matter. So let's consider two individual forces. The same one I keep showing. And let's consider a separate force like that. Assume that they're the same length, so the same strength. The direction's just different. And we want to consider them separately, not being applied at the same time, just one at a time. So my question is, which force will have more torque? All right, well, it's tempting to go with this one because it seems like it's pointing in the direction we want to go. I mentioned we've got to rotate this counterclockwise. But it doesn't work that way. It's actually this one right here, the one that's pointing straight down. Now, it's not the fact that it's pointing straight down. What's more important and how this works is if we go to our pivot point and we draw a line from that point straight out to where the force is being applied, that's called a lever arm. And if you notice, the length or the distance here is really just the distance we talked about in the second factor. All right, so the distance from the pivot. All right, well, the relationship between your lever arm and your force, to get the maximum torque, you need to have those two be perpendicular to each other. So that means that you have a 90-degree angle in between your lever arm and your force. That gives you your maximum torque. Now, any other angle will still give you some torque other than the zero angle, or 180 degrees, but you just get less. So the smaller your angle relative to your lever arm, the smaller the torque that you get. Okay, and that's basically torque in a nutshell. To really work with torque, you need mathematics, and we're not going to go into that. It does get complicated. But this gives us a conceptual understanding, and for most practical jobs like loosening bolts, this kind of knowledge is pretty much all you need. So I found an interesting cartoon on the internet. This shows a guy who seems to be struggling trying to loosen up this bolt. All right, and then this picture, he has a rope attached to the wrench instead, and he has a smile on his face. So to me, that implies that it's somehow better to have this rope. So I thought we would go through and try to figure out if this is true, if that's why he's smiling. Let's assume that using the rope, he's still pulling with equal strength. And I want to ask the question, would the rope result in more torque? So is that why he's smiling? Because there's more torque, or in other words, it's easier to loosen up the bolt. So what do you think? Give that a run through. So I'm going to say no. It would not make it easier to have the rope. And really, we just need to check our three factors that we discussed before. So first of all, strength. We already said that we're assuming he pulls with equal strength. So in the first case, let's go ahead and make that our strength. So the length of that arrow is representing my strength. The direction should be the direction of his arms. That's where he's pulling. So that's why I have it shown horizontal here. And then the distance would be our lever arm, where you draw it from the pivot up to where the force is applied. In the second scenario, we already said the strength is the same. The direction would be in the direction of the rope, so it looks to be the same. And the distance, or the lever arm, is also the same. So long story short, there's no advantage to using the rope. So whatever he's smiling for, it's not necessarily because of torque. It's no easier using the rope. So with this potentially new understanding of torque, next time you see a truck commercial in which they boast about their torque, it'll make better sense why they do that. The whole point of a truck is to get these tires to change their rotation. So more torque is going to give the truck more ability to change that rotation under more strenuous circumstances, like a heavier load, which is why they're boasting about their torque. I'm going to take a break here, end our discussion on torque, and we're going to move on to center of mass in the next video.